So with recursive rules of arithmetic and geometric and then other sequences, we're going to use the first term. So if we want to know what the second term is, okay, all we would do is really just plug in a 2, and we would have a sub 2 is equal to a sub 2 minus 1 plus 3. Now, we're realistically not going to write this all out. Because what is 2 minus 1? 1. What's the first term? So really all we're saying is we're going to take the first term plus 3. Well, what's the first term? 5. So what's the next term in our sequence? 5 plus 3 is 8. Okay? Realistically, you're not going to do all of this to say, hey, it's 8. What are you going to do? You're going to start with 5, and then you're going to add 3 to it. So as far as if I would find the terms, I would just basically say, starting with the first term, so the first term is 5, I add 3 and I get 8. What's going to be the next term? 11. What's the next term? What's 11 plus 3? 14. Okay, and so on, so forth. We would just keep going from there. All we're doing is we're taking the term before it, or the term that I'm currently on, and in this case I would add 3 to get to the next term. Okay. You're most likely not going to plug in 2, plug in 3, and say, well, what was the second term? Well, it was 8, so I'm going to add 3 to that. That's a lot of extra work whenever you can do it, hopefully, mentally in your head. Okay? Or have a little bit of common sense to say, all right, this is what we're at now. I need to add 3 to it, so that's simple math. Whereas, whenever we had, okay, so like this is the recursive rule, okay, that's up here in highlighted in yellow. How would we write? We'll get to that in a minute. Let's do that. We'll do that later. So that's how we write the recursive rule, basically saying, hey, you're going to look at the previous term of whatever I'm on. Okay, if I'm looking at the second term, the third term, fourth term, for me to know the 10th term, I need to know what the previous 9 were. Does that make sense? Okay. So with recursive, I have to know everything that came before it, whereas what you've been dealing with recently and the explicit rules is all I would have to do is take that 10, plug it in, and I could go. Okay. I wouldn't necessarily have to know what the first 10 terms are. Recursive is good as far as if you know where you start and know where you're getting to, but there could be a lot of, the reason why we don't do it is because we don't want to write out 10, 20, 30 terms. We just want to plug in a number to our formula or our rule and get our value. Okay, this is what arithmetic would look like. The next one is what geometric's going to look like. So if we have geometric, if I have a to the first, or my first term is negative 3. What do I need to do to get my second term? Multiply by 2. So what's my next term? Negative 6. What's the next term after that? Negative 12, right? What's the next term after that? Negative 24. Next term after that, negative 48. And then we would just keep going. So if you think about it, that's still the first term. That's still the second term. That's the third term. That's the fourth term. That's the fifth term. For me to get the fifth term, I had to go 5 minus 1 and get the fourth term and multiply that value by 2. I had to look at the previous spot so I could get the next one in line, essentially. Okay? Because hopefully you're not having to plug in 2 minus 1. Well, that's 1. So the first term was -3 and going from there. You're just going to multiply the term that you're on by, in this case, 2. And then to get your following term. Now the next one is kind of a combination of the two. It's neither arithmetic nor is it geometric. Okay, it's that other sequence. Because I'm multiplying going on and I am adding. So the first term here is a positive 4. So my first term was 4. What's my second term? What do I have to do to this 4? Multiply it by 2 and then add 3. So I multiply it by 4, that's 8. 8 plus 3 is then 11. To get my third term, what am I going to do to the 11? Multiply by 2, add 3, so I'm going to get, any takers? 25. To get the fourth term, what am I going to do? What number am I going to multiply by 2? 25. 25 times 2 is 50. 50 plus 3 is 53. And then I would just keep going on from there. Okay. With arithmetic, with geometric, as far as the recursive rules, you can see the form that what we've been doing before this. Okay? We're adding 3. We're multiplying by 2. Here it's going 7, 14, and so on and so forth. There's a lot of other, it's not a consistent adding, or it's not a consistent multiplying, dividing, whatever you want to call it, because it has multiple things happening. It's getting multiplied and it's getting added to it. Okay. Same way here. Okay. Again, these are not arithmetic. They're not geometric. It's in that other category. Okay, because it's not continuously doing the same thing. What is going to be, obviously we should know what our first term is because they give it to us. They tell us on the very first one on top that the first term is 2. So my first term is 2. What's my second term? What do I need to do to that 2 to find the next term in my list or in my sequence? Square it. So 2 squared is 4. 4 plus 3 is then 7. To find my third term, what do I need to do? Square 7. So I'm at 49. 49 plus 3, 52. Okay, what's going to happen to these numbers even more than what the other ones have done? They're going to get bigger even faster, right? So even if I go 52, take 52 squared, whatever that is, okay, and then add 3 to it. Good question. It's not that you're really ignoring it. It just means like the -1 here just means that you're looking at your previous term is what that means. It's not that you're subtracting anything. What you're subtracting is like a sub 3, like the third term. What's 3 minus 1? 2. So what that means is I've got to look at whatever my second term is. It's like to find the next blank, like to find, like if I want to know, hey, what is this number? I've got to go back here and do the squared and then add the 3 to it. Does that make sense? So it's not that I'm subtracting 1, it just means it's like I'm going back to the previous term. Okay? But that's a good question. So, same way even on the second one, okay, I'm starting at -3. Okay, even if I'm starting at -3, my first term is -3. To find the following term, or the second term, I have to square that. So -3 squared is actually going to be a +9, right? +9 minus 1. So it's really 9 minus 1, which is 8. To find the term after that, then what am I going to have to do? I'm going to have to square 8 and then subtract 1 from that. So 64 minus 1 gives me 63. If I needed to find the next term, then I would take the 63, I would square it, and I would subtract 1, and I would get a really large number. Okay? The ones that have a term squared are going to get really big, really fast. Okay? So don't think, man, Laws, that's a really big number. I don't know if that's right. No, you're probably on the right track. Okay? If you're adding, it's going to be the smallest. Obviously, adding or subtracting is going to be one of the smaller jumps. Whenever you multiply, it's going to be kind of in the middle. And then whenever you square it or you take something to the third power, it's going to get really big, really fast. Okay, so just kind of realize that as you go. The next one then is, and this goes back to kind of like Ella's question as far as do we not worry about the -1, or where does that come into play? Okay, so in this case, we're going to look at the previous two terms and we are going to add those together. So what that means is if you have to look at 2 terms or 3 terms, they're going to give you, or I'll give you, or whatever, okay, it's going to give you at least the terms that you need to start. Does that make sense? So if I have 3 and 4, if I would have like my list here of my values, they tell me that the first term is 3, the next term is 4. If I'm at a sub 3, or the third term, all that means is I'm going to look at the first term and the term 1 step ahead and the term 2 steps ahead of it. So what am I going to do with the 3 and the 4? Add them, and I'm going to get 7. To find a sub 4, I'm going to look at, so like for the 7, I took those 2 numbers and I added those together. For the next blank, I'm going to take the 4 and the 7, and I'm going to add those together, and I'm going to get 11. To find my 5th term, or a sub 5, I'm going to take 7 and 11 and add those so I can get 18. Anytime it says like a sub n minus 1 or a sub n minus 2, that means I've got to look at the term right before it and the term 2 before it. And I need to either add, subtract, multiply, divide, whatever. Okay? Normally we won't divide. It'll be mainly add, subtract, or multiply. So, same way then on the second one. If we would just do the first 5 terms. So it gives me, again, it gives me the first 2 terms. So the first term is just 1. Second term is 2. What am I going to do to get the third term? What do I need to do with the 1 and the 2? Multiply them and I get 2 again, right? So then to get the fourth term, what do I need to do with 2 and 2? Multiply them, and I'm going to get 4. To get the fifth term then, what do I need to do with the 2 and the 4? Multiply those and get 8. What would be my next number after that? 32, and then whatever 32 times 8 is, and go on from there. Now, here's where it's not so much that it's really difficult, but it's just a matter of what you have. Okay? And kind of knowing, how do I get the next term? What am I doing to it to get that next value? So, recursive rules are going to be the easiest ones to write in general. Okay? I'll tell you that right now, because to go from 3 to 10, that I have to add, subtract, multiply, divide, what? What did I have to do to go from 3 to 7? Add 7. What did I have to do to go from 10 to 17? Add 7. What did I have to do to go from 17 to 24? Add 7. So then all I'm going to do, I'm still writing this as a sub n equal to, what did I have to do? What did I have to do to get the next term? So if I'm at my first term, I had to look at the previous term and do what to it? Add 7. This is my recursive rule. Now, if we had the same thing, okay, and here's where we're going to write both the explicit and the recursive rule. Sometimes there's not really an explicit rule, okay? There can always be a recursive rule, but there doesn't necessarily have to be a explicit rule to our values. The only time we're going to use explicit rules is whenever it's arithmetic or it's geometric. Okay, whenever there's a common difference or a common ratio. So, if we were going to write an explicit rule, this is just what we've done up until this point. Okay, so hopefully you can kind of see the relation between the two. Remember, for an explicit rule of arithmetic, okay, arithmetic just because we're adding the same number constantly. Remember, we had a sub n equal to the first term plus d times n minus 1. So our first term was 3. Our common difference was 7. So I would have 3 plus 7n minus 7. So my explicit rule is a sub n equal to 7n minus 4. What does the recursive rule and the explicit rule share? The 7. Okay, so it shares the 7. Okay, so whatever we're adding or subtracting by, whenever we write the explicit rule, that's what should be the common difference whenever we have this. Same way whenever we do, what are we doing to go from 1 until the next? From 1 to 4 to 16 to 64, what are we doing to get the next term? Multiplying by 4, right? So then if I'm going to write my recursive rule, if I have a sub n, I need to take a sub n minus 1 and do what to it? Multiply it by 4. Doing the same thing with, if I would write the explicit rule of geometric, I have a sub n equals a sub 1 times r to the n minus 1 power. Well, what's my first term? 1. So I would have 1 times 4 to the n minus 1 power. What number does it share? The 4. Okay. Same way if, now this should be that should be a negative 0.4. Same way here. Okay. Whenever it counts down, usually it is a little more when you go down from one to the next. So from 5 to negative 1 to 0.2. Now, 0.2 is the same thing as 1/5. 0.04, okay, is going to go down to negative 1/25. What are we doing each time? What? Dividing by negative 5 or multiplying by 1/5, a negative 1/5. So since it's multiplying by a negative 1/5, it's still going to be the same thing. Again, like we said, the recursive rule is going to be a lot easier. And again, you can put the negative 1/5 out in front if you want. And then a sub n minus 1. I'm looking at the previous term, multiplying it by a negative 1/5. Same way I would do the same thing for the explicit rule, but it would be negative 1/5 to the n minus 1 power, and then multiplied by my first term. So then even on, so like on one like this where it goes from 5 to 6 to 11 to 17 to 28, does this one continually go up by a constant value, either by multiplying or adding or subtracting? No. Okay, so then it's only going to have a recursive rule. It's not going to have any sort of explicit rule like we've done before. So then whenever I have this, what are we doing to go, like to get the 11, what did we do? How did I get the 11? Add 5 and 6. How did I get the 17? Add the 6 and the 11. How did I get the 28? Added the 11 and the 17, right? So then it just becomes writing the rule of a sub n. So a sub n is like whatever term that I want right now. That I need to take a sub n minus 1 plus a sub n minus 2. All we're doing is taking the previous two terms and adding those together. Same way like on the second one, what did I do to get the second term? Or the third term. Multiply the first two together. Same way whenever I multiplied the fourth, to get the fourth term, I had to multiply the second and the third term together. So then I would just write it out as a sub n equal to a sub n minus 1 times a sub n minus 2. That just means all that n minus 1 and n minus 2 means is I need to take the one right before the term that I'm looking for, and then the term before that, and multiply those two together. Again, they won't have any sort of explicit rule in doing that because there isn't one available, because it's all dependent on whatever our first value is. Okay? Last thing, what I would suggest on any of these where you have to go from either explicit to recursive or recursive to explicit is to basically take what you have, and I would pretty well just take I think from explicit to recursive is a heck of a lot easier. Because explicit to recursive, what am I going to do with that 3? What does that 3 mean that's in front? Then I'm just going to keep adding it, right? So whenever I go from explicit to recursive, it's as simple as a sub n equal to the term before it plus 3. I'm not really worried about the 2. Okay, the 2 is just tells me, hey, this is going to help me get my starting spot. But if I'm going from explicit to recursive, then I'm really not worried about the 2. I'm really only worried about that 3. Same way with whenever it's a geometric explicit rule, what's the only number that I'm worried about? The 1/3. Because that's the number that keeps getting multiplied. So the only thing as far as I'm worried about is just that I'm going to have a sub n equal to 1/3 times whatever my previous term was. If you want to put a parenthesis around it, you can. That's fine. It all means the same thing. But you just have to look at the common difference or the common ratio, okay, depending on which one you have. If you have to go from recursive to explicit, what number am I worried about whenever, because this is arithmetic, what number am I worried about here? The 4. So if I'm going to go to an explicit rule, then I'm going to have a sub n equal to 4n. Now, I've got to figure out what I've got to do on the back side. Okay? So I kind of have to figure out what value goes in the blank. So essentially what I'm going to do is I'm going to use the value that they give me. They give me the first term. I'm going to take 3 equal to 4 times 1. What do I have to do to that? What do I have to do to 4 to get 3? 4 plus minus what gives me 3? Minus 1. So then the minus 1 is going to go right there. All I'm going to do is just plug in the value that I have before, okay, and really just knowing what, if it's going to be, if this is explicit, or excuse me, if it's geometric or if it is arithmetic. So like here, it's a 3. So then if I'm going to write the explicit rule, I need to figure out what number times 3 to the n minus 1 power. So if I have the first term, if I have 6 equals something anything, what's 1 minus 1? 0. So what number is going to go in front there? Now what's my first? Remember, this is what? A sub 1 times r to the n minus 1 power. What number is going to go right here? 6. Because it's the first term.